All right, so I'm going to run through the equation of a line today. So just really quickly going to explain what the equation of a line is and then do two examples of the type of question you're going to be asked to do today anyway. So here is a line, okay, my diagram here is rough enough. There's a slightly better version of this diagram on page 555 in your book. But if you look at this straight line, what is supposed to be a straight line, here's all the points on it. Minus 1, 6, 0, 5, 1, 4, 2, 3, 3, 2, 4, 1, 5, 0, 6, minus 1. So what do you notice about all the points in this line, especially from maybe between those two? So 0, 5, 1, 4, 2, 3, 3, 2. Well, if you add the x and the y coordinate in that line, it's always equal to 5. So x plus y equals 5 for every single point in that line. Well, that is the equation of that line. Okay, so that's all it is. It's a relationship between the x and y values in any point on the line. So if you sub something in for x and y and it adds to give you 5, that point is on the line. Okay, so let's say the point 11 minus 6, if I went all the way over here and down here. Well, if you put 11 in for x and minus 6 in for y, 11 plus minus 6 is equal to 5. So that point would be on the line. All right, let's say 15 and minus 12. 15 plus minus 12 is equal to 3. It's not equal to 5. So that point would not be on the line. Okay, so that's all the equation of a line is. It describes the line in terms of the x and y values of each point on the line. Okay, that's a really simple one. X plus y equals 5. Look, all you're going to see is they'll have numbers in front of the x and y maybe, so you might get something like 2x minus 3y minus 14 equals 0, and that's the equation of some line. Now, it's harder to see straight away what the relationship is there. It's not an easy one here, like where it's just x plus y equals 5. This one's a little bit trickier, but the principle is the same. That is the equation of a line. So your equations of lines should have x's in them with maybe a number in front of it, a y in it with maybe a number in front of it, and a number on its own. Okay, doesn't have to have all three of those things, but I'd say most often it does. All right, so you can be asked to do a few different things with the equation of a line. The first thing I'm going to do today is just finding the equation of a line. Now, like pretty much everything else in coordinate geometry, you're going to find the formula that you need here on page 18 in your formula book. Okay, and if you look, you've got equation formulas here. Okay, slightly different to the other ones in that there's two different formulas. You've got y minus y1 equals m on x minus x1, and you've got y equals mx plus c. The first one is used to get the equation of a line. So my two questions, or my two examples I'm going to do now, find the equation of a line, find the equation of a line. It's the y minus y1 formula I use to do that. So that's for getting the equation of a line. The other one, the y is equal to mx plus c, that's if you're already given the equation in a question. So if you were told it's x plus y equals 5, you can use that y equals mx plus c formula to get information about the line, but I will cover that in a different video. First up is finding the equation. So first example here, find the equation of a line that goes through the point minus 1, 3 and has a slope of 3. And then it just says, write in the form ax plus by plus c equals 0. A, B, C are elements of Z. Z is integers. Okay, so that last bit, the write in the form, I'll deal with that in the end. That's just telling me what my final answer needs to look like. That's a bit like in other questions where it says to 1 decimal place or the nearest whole number or something like that. Okay, so we'll deal with that at the end. First thing I need to do is find the equation of the line. So from page 18, I'm going to get the equation of the line formula. So that is y minus y1 equals m on x minus x1. So there's your formula. Always write down the formula that you're using. All right. Now, if we just look back at what I said the equation of a line looks like, it'll have an x in it typically, it'll have a y in it typically, and it'll have a number in it typically. So you want x and y in your answer is what I'm saying. All right. So to get x and y in your answer, you do not sub in for this x and this y. So the x and y on their own, kind of without a number after them, you don't sub anything in. You're going to leave those as x and y. That's how you're going to get that x and y in your equation. All right. The x1 and the y1, that's a point on your line. Okay, so you're going to sub that in as normal. So the point I'm given is minus 1, 3. So that's my x1, y1. All right. What else am I missing from this formula? M. Okay, so I need m. And oddly enough, m stands for slope in coordinate geometry. Okay, so it's looking for the slope. In this question, I am given the slope of the line. So that's going to be my m, the slope of 3. So I have my x1, y1, my point to sub in. I have my slope of 3 to sub in. The x and y here that I'm not going to sub in for. So I have everything that I need. So fire ahead and sub into the formula. So y minus y1 is 3 equals m, the slope is 3, on x minus in the formula, and then this point is minus as well. So you end up with minus 1, kind of a double negative there. So that's equal to y minus 3 equals 3 on x. Two minuses together make a plus, so that's x plus 1. All right, let's do our multiplying out now. Y minus 3 equals 3x plus 3. Okay. Now you'll get loads of marks for that. I'll go through kind of where they kind of tend to give marks for these questions at the end of the video, but you're going to get loads of marks if you get all that here. But here's where this kind of final line in the question becomes important. All right. So write in the form ax plus by plus c equals 0. A, B, and C are all integers. So that's z with a double line there on the diagonal means integers. So integers, positive and negative whole numbers. So it's telling you it doesn't want any fractions in the answer. It doesn't matter here because I haven't got any fractions in my answer. So ax plus by plus c, that just means something x. So some number x, by, some number y, plus the c there is just some number. And then it's telling me it wants all of those on the left-hand side equal to 0. Okay, so it's telling me to move everything to the left-hand side and leave 0 on the right-hand side. Okay, this is by far and away the most common way they want you to write the equation of a line in an exam question. That's why I'm doing it here. You could be asked to do slightly different things, or it might stay silent on it, and they can't really dock you marks if you don't give it in the exact form, but it's most common that they'll say in this form here. So ax plus by plus c equals 0. Basically, it just means move everything to the left-hand side, and you'll have nothing then on the right-hand side. So I've already got y minus 3 on the left-hand side. So let's move plus 3x over. It becomes minus 3x. Let's move plus 3 over, and it becomes minus 3. And then I've moved everything from the right-hand side. So I'm left with nothing on the right-hand side, or 0 on the right-hand side. So let's just write this the exact way they want. They want the x first, so minus 3x. Then the y, so plus y. And then minus 3 minus 3. Okay, so if you're not too comfortable doing that kind of minus 3, what exactly is that kind of in your head, just check it on the calculator. So minus 3 is minus 6. So it's minus 6. And then, as I say, 0 on the right-hand side. And there is your answer. So something x, something y, number equals 0. So the number in front of the y there is 1. If there's none there, you can put the 1 in, you don't have to. Grand. Other example over here then. So find the equation of a line that goes through the points -4, 5 and 1, 3. Write in the form ax plus by plus c equals 0 again. So look, we'll deal with that at the end. So first thing I'm asked to do here, find the equation of a line, or write the equation of a line. So y minus y1 equals m on x minus x1. So I have to sub 1 point in from the line. I'm spoiled for choice here because I have 2 to choose from. I could pick either one. So I could put -4, 5 in, or I could put 1, 3 in for x1, y1. It doesn't matter, all right? You can put either one in, but just because you've got 2 doesn't mean you sub in for this just x and y. They're always just left as x and y. You do not sub anything in for those ones without the number after. But you're going to sub either one of those points in for x1 and y1. As I say, doesn't matter which one you choose. I also need to sub the slope into this formula, but I'm not given the slope, okay? What's my slope formula? My slope formula is y2 minus y1 over x2 minus x1. So to get the slope of a line, I need 2 points on the line. So while I'm not given the slope in the question like I was in the first example I did, I do have enough information to find that slope. So if you write your slope formula, it's y2 minus y1 over x2 minus x1. All right, so I'll call this x1, y1. I'll call this x2, y2. All right, you could flip that around and call that x1, y1, and that x2, y2. That would also give you the correct answer. Any other way of labeling them is wrong, though, and will give you the wrong answer. So x1, y1, x2, y2, or x1, y1, x2, y2. Let's sub in then. y2 minus y1, so 3 minus 5 over x2 minus x1. So x2 is 1, minus in the formula, and then minus in the point. Okay, so double negative there. Just watch out for those the whole time when you're dealing with these formulas, because a lot of these formulas have minuses in them. So on the top, 3 minus 5 is minus 2. Again, just do that on the calculator if it's going to trip you up, or if it is something that trips you up. On the bottom then, 1 minus minus 4. Again, do it on the calculator if it's going to trip you up, but 2 minuses make a plus, so 1 plus 4 is 5. So there's my slope, okay? Minus 2 over 5, okay? Don't forget now, that's not actually what you're asked to get in this question. You just need to do that as part of your answer. So you need to go back up here and finish off getting the equation, okay? So into my equation formula is going to go this slope, minus 2 over 5, and also one of these points, okay? I've already called this one x1, y1, so I'll just fire it away and sub that into my line. But it would be fine at this point to change your mind and decide you're going to make this one x1, y1 and sub that in, and that'd be fine. And that might be easier because they're both positive, but I'm going to stick with the x1, y1 I labeled from my slope formula. So y minus y1 is 5 equals m, my slope is minus 2 over 5 on x minus in the formula. The point then is minus as well. So I've got y minus 5 equals minus 2 over 5 on x. 2 minuses together make a plus. Okay, so I'm where I was over here. I've got a fraction. That is going to mean it's going to add just a little bit of complexity to the question. It's going to give me another step I need to go through. But for now, let's just multiply this out, okay, on the right-hand side. So y minus 5 equals minus 2 over 5 by x. Well, like anything by, like say 2 by x is 2x, 3 by x is 3x, 10 by x is 10x. So minus 2 over 5 by x is just minus 2 over 5x. And then minus 2 over 5 multiplied by 4. If we're not too sure what that is, minus 2 over 5. Minus 2 over 5. Third time lucky. Minus 2 over 5 on the calculator. multiplied by 4 is minus 1 3/5. I'd probably find it easier to write it as minus 8 over 5 for now. Okay, so there is that's it multiplied out. Okay, I'm almost done here. So this is again where this final line actually becomes important. So write in the form ax plus by plus c. So it wants me to move everything over to the left hand side. But what else does it say? It says a, b, and c are elements of z. So the numbers in front of my a, my b, and the number on its own have to be integers. They have to be whole numbers. I've got fractions here. I do not want fractions in my answer. Okay, so the fractions I have are over 5. So how do I get rid of an over 5? Okay, or divided by 5 is another way of saying over 5. What's the opposite of dividing by 5? Or what's the opposite of over 5? It's multiplied by 5. So if I multiply this by 5 and this by 5, I'll get rid of those fractions. You can't just multiply the right hand side of an equation by 5. So I need to multiply these two by 5 as well. Okay, so I'm going to multiply everything by 5. Okay, and that's going to get rid of the fractions, but because I'm doing it to everything, it's not actually changing my equation. So y multiplied by 5 is 5y, minus 5 multiplied by 5 is minus 25. Minus 2 over 5x, if you want to do that multiplication on your calculator, that's fine. Minus 2 over 5 multiplied by 5. But the only effect it has is the over 5 and the multiplied by 5 cancel, and you're just left with the minus 2. So minus 2x. And then minus 8 over 5. Again, the over 5 multiplied by 5 cancels. It just gets rid of the fraction. That's why we're doing this. So you get minus 8. All right. Now, remember, it wants everything on the left-hand side equal to 0 on the right-hand side. So if you move minus 2x over, it becomes plus 2x. If you move minus 8 over, it becomes plus 8. And then I've moved everything from the right-hand side, so I've nothing left. So it's equal to 0 on the right-hand side. And now just on the left-hand side, in the form it wants, so 2x out in front, then plus 5y, and then plus 8 minus 25. Again, do it on the calculator if you need to. 8 minus 25 is minus 17 equals 0. So there's the equation of that line. Okay, so a little bit more to it if they don't give you the slope. If they only give you 2 points, you need to work out the slope yourself. But from there, it's the same as this question here. As I said, with the added little bit that we needed to get rid of a fraction here. Okay, and that will come up sometimes in exam questions, so you need to be able to deal with that. Now, if you find, I would say that bit in particular, a little bit tricky, the kind of getting rid of fractions. But even this bit here where we're multiplying out and we're moving stuff to the left-hand side, if that trips you up sometimes and you don't quite, let's say you're kind of getting the first couple of lines right and your last line is a little bit off, okay? The last few times this has come up on the exam, it has been worth 10 marks, okay? You've got 4 out of 10 for writing down the correct formula and substituting any number into it correctly. So if you wrote this formula down and you either put the minus 1 in right, the 3 in right, or the 3 in right, the slope 3 in right, that got you 4 out of 10. So you passed the question 4. It asks you for the equation, you write down the equation formula, and if you put one thing into that formula correctly, you got 4 out of 10, you passed the question. If you put everything into the formula correctly, so if you put the minus 1 in the right place, the 3 here in the right place, and the 3 here in the right place, that second line there gets you 7 out of 10. So it gets you 70% of the marks. So as I say, if it's from there on, that's tripping you up a little bit. As long as your second line is right, you're getting 7 out of 10. I'm going to put up the kind of worked solutions from the book for you to correct these, which hopefully have the kind of thing done out in full. So you can see if your second line is what they've got, if everything subbed in is right, that's 7 out of 10, even if your final answer is a little bit off somewhere, okay? Even more very relevant over here, where the multiplying across by 5 is going to trip people up. If you write the formula and substitute anything in correctly, that was worth 4 out of 10 over here. So that would be relevant even if you weren't too sure how to get the slope. If you put 1 or 3 or -4 or 5 into that formula into the right place, that would be 4 out of 10. If you did work out the slope and sub one of the points incorrectly, so you got this second line fully correct, and that could be with the 1, 3 as well, that got you 7 out of 10. So again, 70% of the marks without going near this stuff about getting rid of fractions and moving stuff over to the left-hand side. One final thing just to say about the answers in the book is, I actually haven't double checked yours yet, but often, and it might come up other places if you're checking answers, often if they get the x as negative, like you did in your first example here, -3x, what they do is they nearly like bring it over to the other side. They change all the signs in it. They sometimes want the x to be positive. It doesn't have to be the case. It's just the way they write them in books sometimes. So let's say you've got this answer, but the book has the same answer with all the signs changed. So -3x is +3x, plus y is -y, -6 is +6, and it's equal to 0. That's the same answer. Okay, so if you've got like all the same terms just with the signs changed, if every single sign is different, you've got it right. Okay, they're just writing it a little bit different. But like I said, this is a perfect answer. If you wrote that down in an exam, you'd get full marks. Don't worry about what they're doing there. It's just to kind of cover it off if it seems like you're getting an answer wrong and you can't figure out why. Okay, so there's the equation of the line, the y minus y1 formula. Sub in for x1, y1, sub in for slope. Don't sub in for just the x and the y. After you've subbed in and multiplied out, the most common thing you're asked to do is multiply them out and move them to the left-hand side. I don't think the questions in your book explicitly say they want you to write them in this form, but that's the form all the answers are in. So what I'm doing here in my examples, do that in yours, as in the ones you're doing. Okay, so multiply them out and then move everything to the left-hand side equal to 0.